Welcome to session 2 of what I like to call Make It Move, where we learn how to make it move. It referring to the robots in FRC. So this is our second session, and we are going to, because a lot of people have shown interest in this, we are going to be more a bit introductory with this. So whereas last session we focused on introduction to code, we will talk about this week, we'll talk about introducing the hardware and the software that y'all have to familiarize yourselves with for the next upcoming FRC season. So a little bit about me, just to recap. I'm Dylan Wong. I am a current junior going to Bel Air High School. I was the 2023 to 2024 programming captain for FRC team 2585. Next year, I will be their chief product engineer. So here's my Instagram profile on the right side here. Let me go ahead and turn on my laser pointer and let's talk about some introductory stuff. So for those of y'all who are here for week 1, you might have seen this slide right here. For those of y'all who are new, welcome, first of all. But second of all, you might be wondering, what exactly does programming do? So if you're familiar with any of the programming, if any of the robotics competitions from middle school, elementary school, for example, just to name a few, Vex and Vex IQ, perhaps FTC and First Lego League, if some of y'all do that, you might be familiar with what programming does, and it does these things. First of all, it allows the robot to move. Without programming, the robot wouldn't move at all. And in the case of FRC, code also allows the robot to move autonomously, meaning by itself. So that means that what that entails for FRC is that some competitions have an autonomous section of a match. For example, Vex, the V5, V5RC, has a 15-second autonomous period at the beginning. So does FRC. In the first 15 seconds of a match, the robots run off of autonomous programming. And during autonomous in FRC, points can be scored, a lot of them. So I put mega points here. For example, in the 2024 game, which I'll show you gameplay of which later, in the 2024 game, a note shot into the speaker during autonomous was worth 5 points, while during the teleoperated period, which is the driver control period, it only was worth 2 points. So scoring 2 notes in the speaker and also crossing the autonomous line, which is just moving forward, during autonomous would earn you 12 points, which is equivalent to shooting 6 notes into the speaker. So autonomous is, depending on the game, really useful. Additionally, programming allows you to control the controls, which are the things that the drivers use to drive the robot. It allows you to adapt and change the controls so that they're most comfortable with driving the robot and they can perform at their best. So here's a little visualization I like to show y'all about why exactly autonomous is important. So if you go to the Blue Alliance, which is, by the way, the website it's all things FRC, statistics about every single team, their history and whatnot. If you go to the Blue Alliance, there's a place called Insights, and you can see all of these tables I'm getting this data from. In the 2023 FRC game, during autonomous, on average, an alliance, which is 3 robots on a team during a match, got 7.25 points on autonomous at the World Championships on average. And they scored 18 points in autonomous, all 3 of them, on average at Worlds. That's compared to 52 points during the teleoperated period. So already you're scoring, in terms of like game piece points, not including the end game portion, you're already scoring about a third of the points in just those first 15 seconds. What about 2022? In 2022, if you look on the right table here, 5.71 points for moving in autonomous, and on average, teams scored 4.6 cargo in the upper hub, which was during autonomous, it was worth 4 points in auto, but only 2 points during the driver control period. So autonomous, depending on the game, but usually speaking, it is very, very useful to have. Here's an example of an autonomous that I programmed during the competition season. If I play the video. So as you can see, it starts here. It shoots the note into the speaker. This is on the practice field. Drives forward, takes up that second note, and it also crosses the autonomous line. Boom. That's 12 points right there. So it's very important to have at least a good, decent autonomous for the FRC season. So, what are we going to learn about today? We're going to learn about hardware and software, the basic building blocks of a robot, and how that relates to programming. So, I'm first going to walk you through overview a wiring diagram. I'm going to overview what we use for an FRC robot, and talk about motors and motor controllers. And then I'll also introduce the software that we use as an FRC team. Again, this is just an introductory session here. You don't need to know programming Java in general, but it'd be really nice if you could study up on that before our next session. So, a big shout out to Nicholas Jan and Catherine Huang for submitting an analysis of the amptrap.java class last week. So if for those of y'all who are wondering, if you go into the code channel, you could go to the GitHub that contains the code we used. If you go to the file amptrap.java, I tasked y'all last week with writing an analysis line by line what each code does. You can still do that. You can still DM me about it, but that was the task from last week. So, for those of y'all who are new, first of all announcements pertaining to these sessions will be tagged with @programming. So, if you in Discord, there's a way to mention, for those of y'all who are new to Discord, there's a way to mention users on a certain server. You just @ and then username, but there's also roles on the Discord server, one of them being the programming role. So I will mention the programming role, and everyone with that role will be notified. They'll be pinged, as Discord people like to say. So if you want this role, if you want to stay tuned and updated on all of these sessions, all of the announcements related to these sessions, please DM me. My Discord name is Table of the Americas, though I do have the orange role on Discord, and I do talk in announcements a lot. So you can also find me there. If my DMs are not open, just ping me in general and I'll open them up. But yeah, for those of y'all who are new, first off, thank you for coming. Thank you for joining the Discord server and for your interest in Belair Robotics. And I hope you enjoy this session. So, for those of you who came here to learn programming, you might be wondering, why do we need to know this stuff? And I have 4 reasons up here. The first one is because it allows for the easier diagnosis of problems. So during the season, there's always a conflict. Like whenever the robot doesn't work, is it a code issue or is it a hardware issue? Well, if both people know how the hardware works, and if both people genuinely have an idea on how code works, then it's easier to diagnose these problems and solve them. For example, let's say a motor's not running. Well, it's really useful for the programmer who programmed the motor to move and it's not moving. It's very easy to diagnose the issue if the programmer knows how the specific type of motor works, what software it uses, how it connects to the different mechanisms and the different wiring of the robot, that type of stuff. That way, y'all can work together on diagnosing these problems. In more broadly speaking, knowing how hardware works allows for a better communication between the software and hardware team. We don't really want this disconnect between software and hardware because we want them to work cohesively. We want them to work together. Additionally, knowing how hardware works allows you to configure things. So software and stuff, it's gotten a lot easier nowadays. A lot of motors nowadays are plug and play, but you need to know the software and you need to know the hardware because you need to know, for example, how it connects. Does it connect to the brain of the robot? And I'll explain these terms later. Or does it connect in some other way? You'd have to know this kind of stuff. Because if you know this stuff, then first of all, it takes pressure off the manufacturing team. And second of all, again, problem diagnosis and whatnot. And also, it's just a nice thing to know how hardware works. Because if, for example, we're short on manufacturing, if the manufacturing team suddenly disappeared, or temporarily, hopefully not permanently, if people need to be there to wire, if you know how hardware works, you could wire the robot. You could sub in, basically. And it's good to it's a very nice thing to know hardware. And on the software side, well, of course you need to know software. You need to know how that stuff works. And so I will show y'all a few diagrams. Those should be for reference. It'll be very complicated, but for those of you who are attending Belair next year, it'll most likely be a manufacturing person, a manufacturing lead and officer who will teach y'all how to wire hands-on. Because Wiring from a diagram is not a good idea. In the wiring diagram, I'll show y'all in just, I think, the next slide. It's shouldn't be a guide. As much of it should be a reference. So if you want to learn how to wire and do electrical work, we will do that once the school year next year kicks off and we welcome our new students to Bellaire. Hardware. Let's look at the rev wiring diagram. So here is a full screen of the diagram. So like it's very useful. This is a very useful resource because basically if you go onto any website, it shows you how these things connect together. It's basically a electrical work of the robot. So what I want you to focus on, I want you to focus on these things. I want you to focus on the RoboRio. I want you to focus on the power distribution hub right here, and I will use a different color. I will use blue. I want you to focus on the RoboRio, which is on this side. I want you to focus on the power distribution hub, which is here. And I want you to focus on the SparkMax here, the Falcon 500 here, and I want you to focus on the CAN chain, these wires right here. So, the stuff I want, I highlighted in blue. Only focus on that. Do not look at anything else. Everything else is just a for reference thing. So, for starters, the RoboRio is like the brain of the robot. That's where you're going to connect all of the sensors, the motors, the Ethernet, any cameras. You're going to connect it to power, of course. You're going to connect the robot signal light to it. The RoboRio is the brain. And I want you to then focus on this thing up here. It's this yellow and green. I guess I covered up. But it's this wire coming off on the top left of the CAN up here. That's called the CAN bus. The CAN wiring for the CAN bus. Now, the majority of the things we will use, the majority of the motors we'll use next year, we plan on using via CAN. CAN bus is essentially the way you connect code from the RoboRio all the way to the different motor controllers and motors. So if you follow the CAN bus right here, notice how it's a series circuit essentially. It goes, in the wiring network, it goes to this pneumatic hub. I'm not sure if we'll use pneumatics. And then it goes to all these different motor controllers, like the SparkMax. The SparkMax is an example of a motor controller, and I'll explain this terminology later. And if you follow the chain, and eventually it leads to the power distribution hub, which is this big old black, red, and orange thing. That's where all of the stuff, that's what connects to the battery, and that's where you get all the power from. So all of the power for the motors is connected to the power distribution hub. Again, don't focus too much on this wiring diagram. It's just a reference. Let's talk about these motors and controllers, by the way. So I'll give you some terminology later. I'm going to go a bit faster, so if I'm going a bit too fast, if you need some time to comprehend, I'll obviously give you all the time. Just let me know, speak up, ping me in the chat, mention me. So, the motors are the things that move. So, I'm just going to get some boxes to prepare. So, this right here, that's the motor. That's the thing that spins. So a lot of things in FRC, they spin. Like the wheels spin. If you see in the video, the pivot spun. The wheels on the shooter to take the note out, launch it into the air. That also spun. That's all controlled by motors. So the motor itself is the thing that moves. But most motors have a motor controller connected to it. In order for a motor to work, it has to have a motor controller. That's what this is, for example. So what motor controllers do, and for those of y'all who have it, if you want to interject, feel free to. The motor controller is what gives the power to the motor. So motors by themselves, they don't really do that much. Like you can't, some of them you can connect to the battery and run, but you can't run them at, what if you want to run them at different speeds, in different directions? What if you want them to stop? If you connect the motor to power straight to the battery, you either end up with a burnt motor or a bunch of safety hazards, or you just get a motor that spins continuously until you disconnect it. Well, we need something to send power to the motor, to regulate it, to stop sending power when we want it to stop. We want the motor to stop spinning, and to send power, more power if we want it to spin fast, less power if we want it to spin slowly. That's the motor controller. This thing is smart. This thing, it connects to, well, this one in particular, SparkMax, connects to the CAN bus that I mentioned earlier, and code runs into these, and depending on the commands and whatnot, it sends power. So if you see these wires, some of these wires is code, some of these wires is power. And it sends the power, it connects to this, and this is a type of motor. This is also a type of motor. So this thing connects to this thing, basically. And this thing sends power to it, code runs through it, it's smart. So CAN, I do not have CAN wiring with me, but that was the yellow-green wiring before. That's what code runs through. It's a series circuit. So it starts from the row Rio, and it runs through the chain and it goes to the power distribution panel. Code runs through this. It's the yellow-green wiring, and it connects to this motor. It connects to this motor controller. There's no green wiring here, but trust me when I say there's a lot of this CAN bus out here. So what else is there? Oh yeah, encoders. So encoders are pretty interesting. So inside of most motors, some motors don't have these. Inside of most motors, there's this thing called an encoder. It's somewhere it's deep inside. But what an encoder does, it's very useful. We need it. We need encoders. We love encoders. It tracks how much a motor has spun. It measures how far the motor has spun. There's two types of encoders. There's an absolute encoder, which never resets. So if you turn the robot off and you turn it back on, the absolute encoder remembers its position. Whereas a relative encoder, which is what is inside of these motors, it resets its position once the power is turned off and turned back on. So I'll give y'all a little bit of time to process that. Are there any questions before I move on? Because I'm going to talk about hardware. Why do you need to know how much the motor has spun? I will give you an example. Cat. So, I'll actually, for example, I'll go back to the Tuna Autonomous for this example. So, if the reason why I need to know how far a motor has spun is because we want accurate position tracking. We want accuracy. We want things to be at the proper place. For example, if I ask you, raise your arm, do a T-pose, for example. You want, if you want a robot to do a T-pose, the robot has to know where its shoulder is. So that sensor inside, that's the encoder. So in this example, we have this shooter right here. That has the note carrying inside of it. And so if I play the video, it tracks movement, how far the motor has moved. If I play the video, notice how, Notice how when it moves to this position, it needs an encoder to know if it's at the correct position or not. Because if it's too far forward, it's going to shoot the note, it's going to hit here. And if it's too far this way, too far up, it's going to shoot the note upward and it's going to miss the speaker. So that's why we need to know, encoders have to know where their position is. So a relative encoder, it's also really useful because you could just put the robot in a default position and then turn it on and it will always be at 0. So relative encoders, they just think of it as when you turn a motor on a robot on, the relative encoder is at position 0. So if you could put it in position 0 every single time, put it in the down position and you turn it on, it'll always be accurate, theoretically speaking. Does that answer your question? Yeah, so the pivot motor uses a relative encoder. And when we turn the robot on, we always make sure that the pivot is at 0. It's always lowered, so it works well. All right. So let's talk about some motors. First of all, we have the sim motor. The sim motor is the workhorse. It's a very cheap, accessible motor, and it gets the job done. There's no built-in motor controller or encoder. We have to use these Talons right here. We didn't really use them a lot this season. If you're wondering, every year, like I think starting this year, first it started to release what's called the Kitbot. It's a very basic robot that can do like one game function. It can still like it drive around, it can acquire game pieces, it could score it. It's nothing flashy. It's just a really easy to build robot. That comes with the sim motor because it's cheap, it's affordable. And a lot of teams use it. It's a very popular just prior to COVID-19. It's still popular now, though other options have become more popular as the prices come down. But you can get one of these for like $50. It's a very powerful motor. So, for example, this was the drive, like a basic tank drive chassis. And we drove it around. It was the very beginning of the build season, which is like, it's the very beginning of build season. So this is the chassis we drove around. And so as you can see, it drives, it moves. So there's that. We didn't use that for the season, by the way. And then these are Talons. These are an example of a very basic motor controller. So far less advanced than these. These are more like me send power to motor, and it connects directly via PWM. So it connects directly to the Robo Rio. It doesn't connect via the yellow-green wiring, the CAN wiring. So this is, we use this a lot, Spark Max. So the 3 boxes I have here, these are all from a company called Rev. Rev makes a lot of robotics products. They're relatively affordable, and they work pretty well. This is a Spark Max. This is the motor controller for these 2 motors. We got the Neo and we got the Neo 550. I'll show those later on. So this is a Spark Max. So it's more advanced. It supports relative encoder. So that's if you were wondering, relative encoders connect I believe up here, and then the absolute encoder, if there is one, connects here. You can put absolute encoders are they're not built in usually. They're usually like another hardware piece you have to install on like a shaft or something, and then it connects to a motor controller. And so it uses CAN wiring. The CAN, I believe, goes up here. Though I am not part of the manufacturing team, so if you want to correct me on that, feel free to do so. So yeah, that's the Spark Max. It's once you get the software down, it's pretty easy to use. It has a lot of functions. So yeah, you don't really need to know. This is more manufacturing stuff, but this is just a general overview. That stuff connects to the Spark Max. I don't think I need to tell y'all like where things go just yet. Because again, I do not want to teach manufacturing and building on a screen. I want y'all to learn it in real life, in person. So these are the 2 motors, the Neo and the Neo 550. The pair with the Spark Max. We used that for our swerve drive this year. So this is a little bit of this is a close-up of a swerve module. There's 4 of them on each robot, 4 wheels per robot. So yeah, Neos are generally more powerful. They're bigger. Neo 550s are smaller. So here's the Spark Max. This is the absolute encoder. It connects to this Neo 550 right here. You can see the CAN wiring, by the way, coming out of each of these 4 motors, as well as the power cables. This is the Neo brushless motor, and this is the swerve module. So there's a lot going on here. This is the swerve module. This is the drive face we ended up using this year. And the neat thing about swerve, I don't want to get too much into manufacturing and hardware, is that it could go side to side, it could turn around, it could do all these neat things. It has so much range of motion, better than a tank drive. So yeah, that's the Neo and the Neo 550. This is what we used starting. This is like new to us this year. Krakens. They're very powerful. They're very loud, and they're very expensive. We use these on our shooter to get the notes up to shoot. We need a powerful motor. They have a built-in motor controller. That's this Talon. The Talon FX is the motor controller. The Kraken is the motor itself. The CAN wiring is supposed to connect here in the back. The shaft that turns is here. And if you want a visual or an auditory representation of how loud a Kraken is, here's this video. I don't think y'all, I'm not sure if y'all got the audio there, but it sounds like a buzzsaw. Zzz, like it's very loud, but it's very powerful and it works. We plan on using more of these next year, but they're so expensive. Like $200 for a motor is diabolical. But they work. They're from a company called West Coast Products. They make pretty good stuff. So yeah, that's the hardware. So just a quick rundown of what we use on our 2024 robot. These are all of the NOT motors. So we had a battery, obviously a circuit breaker, a power distribution panel, the Robo Rio. These things I will talk about in a later session. We had a camera, a gyroscope. On the next slide, we had 15 of these things, of these Spark Maxes. We had 15 of these. We had 7 of these. We had 8 of these. And then we had 2 Krakens. So the Krakens were here and here. So I don't want to point out all of this stuff, but just this is hardware. All right. Getting into software, I'll talk about the stuff that we use this year. So the first and foremost is WPI Lib. This is the coding environment. So for those of y'all who have used Visual Studio Code, WPI Lib runs off of VS Code. So if you've used VS Code before, you shouldn't have too big of a problem using this. But I will use a more in-depth guide in session 4 for this. So this is the coding section. It allows you to create projects for FRC, and it's usable for Mac or Windows. But we do use Windows there because this is the only software that is compatible for Mac. You could code on Mac if you have a MacBook. I'm using a MacBook right now, but we use a different laptop in robotics. So if you have a Mac, you could code. You could do the thing like build the code, but you can't deploy it because you need a bunch of other software to run the code itself. Speaking of running the code, FRC game tools. So this is these are the essentials, right? You need this stuff for a robot to work. Kevin, can you please mute yourself unless you have a question? Thank you. So the FRC game tools, these are the essential things you need. So it includes the driver station. So this thing down here, this is what's going to be open during a match. And it has all the information you need. It has the console right here. You can enable it, disable it right here. You could switch the modes. For example, teleoperated means driver control. Autonomous means autonomous. And there's also a bunch of different information down here, like settings and whatnot. The Robo Rio imaging tool, it's not on here, but that's what you use to configure your Robo Rio. Make it competition ready. This right here is radio configuration. And this is what you need to establish wireless communication, which is required for your robot, etc., etc., etc. And this is only available on Windows. So if you have a Windows computer, you're in luck. You could use these things. We do have a Windows laptop that we use as our driver station computer. Right now, I believe is at campus, locked in a closet. But these are the FRC game tools. You need these alongside with WPI Lib to make the robot move. Smart dashboard and shuffleboard. So you know how on your car, you have, if you like, I don't know if you guys are old enough to drive, but above the steering wheel, there's like a speed gauge and a speedometer and like the rev counter. There's like the fuel left and whatnot. A bunch of information that you need to know when you drive. That's what smart dashboard and shuffleboard do, except for your robot. So what this software does is it tracks certain variables on the robot. For example, encoder positions, like for example, like how high the pivot is, where it is, how high the elevator. You have an elevator on your robot. How high is the elevator? What direction your robot's facing? Like you can read off the gyroscope heading. All of that information is fed real time to the smart dashboard and shuffle. So smart dashboard is this on the left side, and shuffleboard is on the right side. Shuffleboard is what we use, but smart dashboard is like the kind of like the class, the bit of code that you need to use to get this running up. So smart dashboard, really useful tool. You need it. I'll say it's not a need, but it's a very, very, very important thing to have because you want to know what is going on in your robot without having to look at it all the time. You want to see what's going on. This is the Rev hardware client. This is where you configure all things Rev. So the motor controller, this motor, that motor, this is where you configure the Rev stuff. So as you can see, when you go into Rev hardware client, once you connect to the robots, you get a bunch of these on the side, and you can click on each motor controller that's connected to a motor, and you can do a lot of things like run the motor, check encoder positions, calibrate the motors, do some settings, all of that. Update firmware, the important stuff. So that's what Rev hardware client does. It's all things Rev. And finally, we have Phoenix Tuner X. This is where we configure Krakens and anything CTR products related. I have a question. How do you connect to the bots? So for Rev specifically, every single one of these motor controllers comes with a orange USB-C cable. You connect. So like what's cool about these is that they have a USB-C. It's not visible here, but all of these have a USB-C port on them. The way you connect it is you plug in the USB-C port to this, and you connect the other end to your computer. And if all of these are linked in a CAN chain, it'll actually detect all of the Spark Maxes on your robot, not just this one. You can edit them all through there. But different motor controllers have different ways of connecting to your computer, such as Phoenix Tuner X, which uses connections to your Rio and your CAN bus. So speaking of, this is Phoenix Tuner X. It's new to our team. We just started using it, and it helps configure CTR products, such as the Kraken X60, that powerful, expensive, loud motor that we just started using this year. So this is a look at the software, the UI user interface. So it's very advanced, a lot of stuff on it, but I'm not like, this is not supposed to be a detailed software guide video. It's just an overview of the software that we use. This is Phoenix Tuner X. Oh, are there any questions before we move on? Have a question from Cats. What does the CAN bus do again? Yes, the CAN bus is the code side. So every motor controller connects to a motor, first of all, but every motor controller has to have code run to it to work, to follow commands that you set for it. So the CAN bus is how that code is carried around. So the CAN bus, it's the green, if I may, if I go here, yes, this is a good example of it. So the CAN wiring is this green-yellow wiring right here. This is what code runs through. So this end connects to like the Rio, and then it goes to all of your devices, and then the other end connects to the power distribution panel. So that's how CAN bus works. It's a general overview. The wiring itself, the line is, it just goes straight to it goes from the Rio to each motor controller. It does not go to the motor. The motor controller is what unifies all of the motor related stuff. So the CAN bus is the term. So just to clarify, the CAN bus is the term used for the CAN, like all of the CAN network. So the wiring, the different stops along the way. So think of it as like a bus route, right? It starts in one place, it goes to each of the stations, and it ends in another place. That's the CAN bus. It's the term used. And each stop you could think of is a motor controller. So like if you think about the wiring as a bus route, the motor controllers are the bus stops. And it goes around and it ends. So the CAN wiring is what code runs through, and it connects to the motor controllers. Yeah, the Rio is like the brain of the robot. That's where the CAN wiring starts. But again, this is all wiring related stuff. It's not really hardware. Like it's stuff that's best taught in person. So yeah, the Rio is getting the code is being uploaded to the Robo Rio, and it's going from there. You connect the Robo Rio to the computer via the radio or the USB port. Okay. Any other questions? All right. Use your task. Nothing. So this week was just this week was supposed to be like a very good introductory meeting, especially for the new people here. So I won't like give y'all like a task because there really is nothing to do. Because like, what am I gonna do? Make y'all download the software and explore the UI? It's nothing really to do if you don't have anything connected to it. This is just an overview of what software we use. A quick like guide through a crash course, if I could say. So just good luck on final exams for those of you who are going to Belair. For those of you who don't go to Belair, good luck on your final exams as well, if you have them. And yeah, are there any questions about anything we talked about today? Hello? I cannot hear you that well. Your microphone is cutting off. I apologize. I cannot hear you that clearly. Can you private message me, and I could address your concerns? Okay. Yes. Yeah. I don't know. This is a first souvenir, but like they just came in handy. Like if I had a Kraken box, I would also get one of those. I'd also keep those. But if there are no more questions to be asked, if there's no like questions, comments, concerns, y'all are free to go. Thank you guys for another successful meeting. And I will see you guys next Friday at 8 p.m. Central Daylight Time. So about 47 minutes ago, but 1 week later. So I'll see y'all at 8 p.m. on June 7th. Enjoy have a great rest of the school year. Y'all got this. Fun finals. I don't know, maybe y'all have like a 95 and you need like a 40 on the final. I don't know. I'm not sure what's going on. But good luck regardless, and I will see you guys next week.